All right, now that you guys should be comfortable with solving trig equations algebraically, I'm now going to show you the graphing approach. The graphing approach is nice. It's quick. It's not too hard to work with. Another good thing about it is it can be used to solve really complex trig equations in which it's proven to be very difficult. So there's two ways you could solve by graphing here, and you should have used these methods quite a few times with all the previous chapters, but you can identify the zeros of a related function. So in other words, bringing everything to one side and making it equal to 0, or you can graph each side of the equation and find the intersection points. So here's my first example here. We wanted to First of all, I want to determine graphically the approximate solutions to the equation of 1 plus 2 cos theta is equal to 3 sine theta in this given domain. So what the domain will tell you is the range, the window range for your x values. Okay, so always keep in mind what your domain is, because that will help you set your window. So let's go ahead and look at this equation first of all. So as you can see here, it's quite a complicated equation, because not only do we have a cosine in here, but we also have a sine theta involved here. So I'm going to use method 1. I'm going to bring everything to one side and make it equal to 0. So I get 1 plus 2 cos theta. Subtract 3 sine theta. And if I bring everything to one side, make it equal to 0, I'm essentially trying to find out what are the x-intercepts. Because if I know what the x-intercepts are, that will actually give me my solution. In this case, it should be theta intercepts. But for the sake of graphing, I'm just going to go ahead and use x. So let's go to y equals, make sure you're in the right mode actually. So we should be in radian mode. So y equals, we're going to graph 1 plus 2 cos x minus 3 sine x. And let's go to the window for a minute here. So my x min, we want to go from 0 to 2 pi. So I'm actually going to set it exactly the way it looks. I'm going to go from 0 to 2 pi. All right, so I'm going to put in a 2 pi. You put it in exactly the way it looks. It gives you actually more precise answers that way. For this scale, just leave it as 1. Y min is currently 10 and Y max is 10. I'll just see how that looks for now. If we have to make any adjustments, then we will. So it looks like this is the only graph I'll get here. So between 0 and 2 pi, you'll see that we actually have 2 zeros. So therefore, we have 2 solutions. So you may have used this option in the past. If you go second trace, select 2 for 0, that will tell you what your x-intercepts are. And once again, this becomes a very easy tool to use, especially if you're working with solving equations. So I'm going to go ahead and find the first one. So you want to essentially get your cursor over to the left of that first x-intercept. So about there would be perfect. So press enter and press enter again. And so your first solution for x to the nearest hundredth of a radian is 0.87. Okay, so 0.87 radians is the first one. And we have to find the second x-intercept. So second trace, select 2 for 0 again. And we're going to take our little cursor and get onto the left of that x-intercept. So you could select a point just about there. Oh boy. Okay. And let's back up a little bit. So right there is perfect. And then to the right and enter. And so our second solution is at approximately 3.45 radians. And that's pretty much it.